Welcome to the Explainer. Today we're digging into a really big question. What if all those simple spreadsheets your business relies on could be, well, transformed? I don't just mean cleaned up. I mean turned into powerful, intelligent assets that actually help your entire company learn and grow. We're going to look at how a platform called SDC Studios is trying to do exactly that.
So to really get a grip on the problem they're solving, let's start with something you probably remember. You ever played the telephone game as a kid? You whisper a message to the person next to you, and they pass it on and on down the line.
And what always happened? The message started out perfectly clear, right? But by the time it got to that last person, it was just total, hilarious nonsense. Well, believe it or not, that exact same thing is happening every single day inside your organization with its most important asset, its data.
We're calling this the data telephone game. It's what happens when data gets passed from one department to another, gets reinterpreted for a new report, or gets manually copied and pasted. You know the drill. With every single handoff, the original context, the meaning, gets a little bit weaker, until the final result is just, well, unreliable.
Okay, so let's really dive into this. To see how we can actually stop this game from happening, we're going to compare the old-school, manual way of building a data model with a much more modern AI-powered approach.
And this slide just perfectly lays out the difference. Look at the old way over there on the left. You've got a domain expert trying to explain what they need to a developer through endless documents and meetings. It is a long, complicated chain with so many places for things to go wrong. Now, look at the new way on the right. The expert just works directly with the AI. All those middlemen? Gone. The whole process is incredibly simplified.
And this table, wow, it really spells out the impact in hard numbers. The timeline just shrinks from weeks down to a matter of hours. The team goes from a whole group of specialists to just one domain expert, the person who actually understands the data in the first place. And maybe most importantly, look at that last row. The knowledge becomes institutional. It gets captured by the system, instead of just walking out the door when a consultant's contract ends.
So, how does this transformation actually happen? Let's pop the hood and take a look at the AI process that turns a basic CSV file into a rich, meaningful semantic asset.
It's all about this 5-step AI-driven pipeline you see here. It all starts with a simple upload. From there, AI agents analyze the file structure and what's inside. But step 3, enrich, that's where the real secret sauce is. This is where the system intelligently links your data to standard business concepts. So that column you called BP is now formally understood by machines as systolic blood pressure. From there, it builds the model and generates the final machine-readable stuff.
And this is absolutely the crucial point. The output isn't just a tidier spreadsheet. It's a semantically rich model. What does that mean? It means the data is now embedded with verifiable meaning. It actually understands its own context, and that makes it instantly ready to use in really advanced systems like knowledge graphs, RDF triple stores, and document databases, the kind of stuff that powers modern AI.
Okay, this is where it gets really powerful. Because the true payoff here isn't just about speed. It's about creating an organization that actually learns from its own work, building what the system calls institutional memory.
Let me walk you through a quick real-world example. Imagine in month 1, a cancer research team uploads a file. The AI helps them create a model for a key piece of data, and they decide to call it tumor size. Simple enough.
Okay, now let's fast forward 6 months. A totally different team. Maybe they're working on oncology trials. They upload their own data. Their file has a column for the exact same thing, but they happen to call it tumor_diameter. In the old world, this would just create a duplicate, a contradiction, a mess. But this is where the magic happens. The platform uses a system called Retrieval Augmented Generation, or RAG. You can think of it as the system's long-term memory. It retrieves information it already knows to improve what it's doing now. So it scans its memory, finds that tumor size component from 6 months ago, and proactively asks the new team, hey, this looks a lot like something we already have. Do you want to just reuse it?
And this creates a huge shift in how companies work. Instead of some committee trying to force standards on everyone from the top down, the best, most useful standards just emerge naturally from the bottom up, based on how people are actually using the data. It's collaborative, not a dictatorship.
The result is what you see right here, an exponential value curve. That very first model, it might take 4 hours, but because the system learns, the 5th model is suddenly 50% faster. It only takes 2 hours. Why? Because it can reuse parts it's already built. By the 10th model, you're down to just 1 hour.
And this effect just keeps getting stronger. By the time the organization gets to its 20th model, the time it takes has dropped by a staggering 87% down to just 30 minutes. That's a powerful network effect right there. Every new model makes the entire system smarter and faster for absolutely everyone.
So, this brings us right back to where we started. The goal isn't just about making data modeling faster. It's about ending that data telephone game once and for all. It's about turning all those scattered files into a single, self-improving brain for your company. So the final question I'll leave you with is this. What could your organization achieve if it could actually learn from its own data automatically?